Hello friends, in this video we will be discussing cycle detection in undirected graph. So this problem can be solved by using DFS algorithm, and this is a important application for DFS algorithm. Okay, so there will be an undirected graph and we need to check whether there is a cycle or not. If there is a cycle, we need to return true, else return false. Okay, so now what is a cycle? Suppose we are going to start from vertex 1. While traversing from vertex 1, we again return back to the same vertex, vertex 1. It means that there is a cycle. So with the help of the cycle, we are again returning back to the same vertex which we have already visited while traversing the graph using DFS algorithm. Okay, so in order to mark whether our vertex is visited or not, what we are using in DFS, we are using visited array. So this visited array will keep track of each vertex and it will say which vertex is visited. Okay, so the code is quite same, just we need to add 2 to 3 logic in order to make our code solving this problem. So the code is similar to DFS algorithm. We have already discussed DFS in my previous video. Okay, so suppose we are going to traverse from vertex 0. From vertex 0 in DFS algorithm, the next step was to explore vertex 0, and while exploring its adjacent vertices, the moment we are finding unvisited adjacent vertex, we will leave this vertex and start exploring unvisited vertex. So suppose our starting vertex is vertex 0. Initially it was false. Now vertex 0 is already visited. I'll change it to true and start iterating its adjacent vertices. So its adjacent vertices are 1. So from 0 I move to 1. Okay. Now from 1 we can move to 0, can move to 2, can move to 3. But suppose if from 1 we move to 0, so it is not possible because in visited array 0 is already visited. Okay, 0 is already visited. So this problem has a logic which we need to write it. Okay, so the main logic is, see, as the graph is undirected and 0 is already visited, so if you think like if 0 is already visited, it means that we are returning back to the same vertex. It means there is a cycle, which is totally wrong. Okay, so the problem is, suppose you are moving from vertex 0 to vertex 1, 0 is already visited. Now from 1, you are traversing its adjacent vertices and you again move back to vertex 0, and in visited array you find that 0 is already visited and you are returning true that yes, cycle is there, which is wrong approach. So in order to prevent this, you need to maintain an extra variable, that is parent variable. Okay, so this parent variable will help to know the parent of each vertex. Suppose from 0 you went to vertex 1. So now vertex 0 is the parent of vertex 1. Vertex 0 is the parent of vertex 1. You again move back to vertex 0. You are checking in visited array that 0 is already visited, plus 0 is the parent of vertex 1. From 0 you went to vertex 1 and from 1 you are again returning back to the parent. So if this is the case, then there is no cycle. Okay, so this problem is being solved by using parent variable. Otherwise in undirected graph you will be returning back to the same vertex while traversing the graph, because the graph is undirected. You will definitely returning back to the same vertex. So in order to avoid this, we will be using parent variable to mark that we came to a vertex from parent vertex. So if I'm going to start this problem solving with the help of DFS tree, okay, so this is my graph. This is my starting vertex from where I will be traversing. This is visited array, and this is -1, which is the parent of vertex 0. So initially there was no parent. There is no parent of vertex 0. So I'll start it from what -1. Now from 0 we went to vertex 1. Okay, we went to vertex 1. So from 0 we went to vertex 1, and now our parent variable changes from -1 to 0. It means that vertex 1 has a parent vertex, vertex 0. We reach in vertex 1 from vertex 0. So parent variable gets changed from -1 to 0. Now again we will be traversing from vertex 1 to its adjacent vertices, and we went to vertex 2. Now from 1 we went to vertex 2, and parent variable gets changed from 0 to 1. Okay, parent variable gets changed from 0 to 1. Now from vertex 2 we went to vertex 3. Basically we are using DFS algorithm. So from vertex 2 we went to vertex 3, and parent variable changed from vertex 1 to vertex 2, because parent of 3 is what? Parent of 3 is vertex 2. Okay, now from 3, which all are the adjacent vertices? 1 and 2. Suppose from 3 we went back to vertex 2. So if we went back to vertex 2 in visited array, vertex 2 is already visited, plus vertex 2 is parent of vertex 3. So we need to check this extra condition. We need to check this extra condition, that whether it is parent of current vertex or not. So suppose from vertex 3 we went to vertex 2. Vertex 2 is already visited, and moreover it is a parent of vertex 3. It means that it is not a deciding factor whether there is a cycle or not. Okay, because we are again moving back to the parent only from where we came to vertex 3. So the next adjacent vertex is vertex 1. So suppose from 3 we went to vertex 1. Now parent of vertex 1 is 0. Parent of vertex 1 is 0. Okay, and from 3 suppose we went back to vertex 1. So parent of vertex 3 is what? Parent of vertex 3 is 2. So this 2 is not same as our vertex 1. It means 1 not equals to 2. So we are returning back to vertex 1, not with the help of parent vertex 0, but with the help of other vertex, that is vertex 3. So this factor decides that yes, there is a cycle. So basically there are two factors. One is visited array. We need to check whether vertex 1 is visited or not. So vertex 1 is visited, plus we are returning back to vertex 1 not with the help of its parent vertex 0, but with the help of other vertex. Okay, so vertex 3's parent vertex is vertex 2, and vertex 2 is not same as vertex 1. So it means that there is a cycle. So this is the main thing which we need to implement in our code to check. Suppose we are in vertex 3, we have visited 0, we have visited 1, 2, and now we are in vertex 3. Now it can be possible that from vertex 3 we again return back to vertex 2. But this is not a deciding case that there is a cycle or not, because vertex 2 is already visited, plus vertex 2 is a parent of vertex 3. So we are returning vertex 3 from vertex 2, and again we are moving back to vertex 2, which is a parent of vertex 3. So this is not making a sense, not indicating that there is a cycle. So now from vertex 3 if we move to vertex 1, then it means that there is a cycle, because vertex 1 is already visited, and vertex 1 is not a parent vertex of vertex 3. I am repeating it again. Vertex 1 is not a parent vertex, because parent vertex of vertex 3 is only 2, and parent vertex of vertex 1 is 0. Parent vertex of vertex 1 is 0. So it means that there is a cycle. So cycle is basically this. Okay. So by this way we can solve this problem. Okay. So the input is an undirected graph and we need to detect a cycle. Basically, this is a function based problem in Geeks for Geeks. You will be getting graph and this number of vertices as its input, and we need to write the code. Okay, so first what I have done is that I have created a visited array and initialized it with false. Okay, all its vertex with false value. Then in order to handle disconnected graphs, I have applied this for loop, and inside this for loop what I will do is that I will call my DFS function for each vertex. So first of all, for each vertex, for vertex starting from 0, I will check whether this vertex 0 is visited or not. So if it is visited, like if it is not visited, that visited of 0 equals to false. So I'll call for DFS. Okay, so I'll call for this DFS which will detect cycle. So if it is true, return true, else return false. Okay, so now I'll go to this DFS, and what I have passed is the starting vertex, graph, visited array, and parent variable -1, because parent of starting vertex is 0, is nothing. Okay, so in order to describe nothing, what I have done is that I have written -1. So now this DFS function will call this, and this is my starting vertex from where I'll start DFS algorithm, graph, visited array, and parent. So now first I will mark that vertex inside visited array as true because I have visited it, and right now I'm going to explore its adjacent vertices. So I'll explore its adjacent vertices using this iterator, and if while iterating, if I get any unvisited vertex, if this is false, as iterator is my pointer variable, so star it will give me the value, that is the vertex value. So if visited of any vertex is false, just leave this current vertex S and start exploring for next, for that unvisited vertex. So now I'll be exploring for star it, and now my parent variable will change from -1 to S, which is the current vertex. Okay, so this is very simple and easy to understand. Like from vertex 0, we are going to traverse, iterate its adjacent vertex. Suppose we got vertex 1 as its adjacent vertex unvisited. We will leave 0 and move to vertex 1. So we are reaching in vertex 1 from vertex 0. It means 0 is our parent vertex. It means starting vertex or the current vertex to which I am exploring, I am iterating will be my parent vertex for the next unvisited adjacent vertex. Okay, so I'll call for star it, and if this DFS function will return true, then I will return true to the caller, and finally will return back to the main function and will print true. Okay, so from vertex 0, suppose I visited to vertex 1, and now from vertex 1 I visited to vertex 2. From vertex 2 I visited to vertex 3. Now from vertex 3 there are two possibilities, that is vertex 1 and vertex 2. So if I move back again to vertex 2, I will be finding that 2 is same as the parent vertex of 3. So parent vertex of 3 is vertex 2, and it is same as that vertex 2 to which I am like visiting. So it is not deciding regarding the cycle detection. So suppose from vertex 3 now I move to, like from vertex 3 we find 1, that is vertex 1 as its adjacent vertex. So if condition will return false because vertex 1 is already visited, so we will return to the else if section, and in else if section star it is vertex 1 and parent of vertex 3 is 2. It means that star it is not a parent of vertex 3. Okay, so it will return true to the answer.